Hi everyone, welcome back to our weekly session. So today we'll be doing this question on chemical bonding, specifically on VSEPR theory, shapes and bond angles. So in this question, we have to take note of two things. Number one, we are looking for the pairs with similar shapes. And number two, where the first species has a smaller bond angle than the second. So let's look at A, PCl5. Now P has 5 valence electrons. Since there's 5 Cl atoms, it just means that it has 5 bond pair and 0 lone pair. Therefore, it has the trigonal bipyramidal shape. So trigonal bipyramidal looks like that. You can remember it as it has both a trigonal planar and a linear. And together they make up trigonal bipyramidal. So over here, between these two angles is 90 degrees and between these two is 120. What about PBr's 5? So P again has 5 valence electrons. So same thing because there's 5 PBr. So 5 bond pair, 0 lone pair, trigonal bipyramidal. So I'm not going to write it again. But there's just one difference. Br has one additional electron shell. So hence the bond length is longer than the PBr bond. And then we also know that Cl is more electronegative than Br. Hence the PCl bond, in the PCl bond, the shared pair of electrons will lie closer to the Cl because being more electronegative means that the Cl atom has greater ability to attract the shared pair of electrons towards itself. Okay, so it looks something like that. Okay, and then whereas for PBr, it looks something like that. Because Br is not as electronegative, therefore the electron pairs are in a more central region. Okay, now let's think about it. Okay, so PBr, I have longer bond length. So if I have longer bond length and the electrons are closer to the middle point, this means that they're not so close together and it face less repulsion. So if it faces less repulsion, so therefore it means that the bond angle is smaller than 120. So hence, looking at this, they have similar shapes. However, the second species is the one with a smaller bond angle. So A is out. Next, let's look at B, PH3. So P again has 5 valence electrons. And since there's 3 hydrogen around it, there's going to be 3 bond pair. The 2 remaining electrons together form 1 lone pair. And this is trigonal pyramidal. And trigonal pyramidal, it will look like that. Because there's greater repulsion between lone pair and bond pair. So therefore, this is why the bond pairs are closer together than the lone pair. So this is 107 degrees. And then next, your NH3 and also has 5 valence electrons. And so, since there's 3 hydrogen, there's going to be 3 bond pair and 1 lone pair. So it's also trigonal pyramidal, and therefore it also looks like that. So they have the same shape. However, N is more electronegative. So therefore, it will attract the electrons closer to itself. P being less electronegative, it will not attract the electrons as closely towards itself. Hence, the bond pair of electrons will be further away. So look at NH3. Since the bond pairs are close together, therefore there will be greater repulsion. Over here, the bond length doesn't really matter because P and N are in the same period. Therefore, they have the same number of electron shells. Therefore, there will be no significant difference to the bond length. So if there's greater repulsion, then there will be a larger bond angle. So more than 107 degrees. So hence, this fits the bill. Both of them have the same shape, trigonal pyramidal, and the first species, pH3, has a smaller bond angle than the second. Hence, the answer is B. Next, CO3 2-. So over here, when you are drawing the dot and cross diagram of anions, you must take note that they have gained electrons. So the gained electrons always goes to the more electronegative atom, because the more electronegative atom has greater ability to attract it towards itself. So C has four valence electrons. Carbon has 4 valence electrons. And for oxygen, it can only achieve octet if it has either a double bond or a single bond, provided it gains an additional electron from elsewhere. So over here we have CO3 2-, so it gains 2 electrons from elsewhere. So therefore we can distribute that to 1 each. So this is CO3 2-. We commonly write it this way. Okay. So over here, since we treat a double bond as a single bond pair, there's 3 bond pairs, 0 lone pair, and therefore the shape is trigonal planar with 120 degrees. Next, I have NO3-. So N, I have 5 valence electrons. Okay, so since it gains 1 electron since it's negatively charged, what that means will be that I can form a double bond, 1 single bond, okay, and then the remaining one has to be a dative bond. So this is what it looks like, NO3-. So if I look at it, it will be 3 bond pair, 0 lone pair, since dative bond is also considered as a bond pair. So therefore, it will also have the same trigonal planar shape. Okay, so then let's look at the two of them. C and N are in the same period. Therefore, there's no significant difference in the bond length. What about electronegativity? Between N and C, N is more electronegative. Hence, N and O is closer electronegativity. Therefore, the bond pair will be closer to the middle. And for CO bond, the oxygen will be more electronegative than the carbon. Therefore, the bond pair is closer to the oxygen. Okay, just to take note that this is a dative bond, hence it should be both crosses. Okay, so over here, technically, it looks as though since the bond pairs are closer to the central atom in NO3-, so therefore there should be greater repulsion, and therefore NO3- should have a greater bond angle. But you notice that we have an issue. If that's the case, then C should also be correct, because both of them are trigonal planar, and CO3 2- will have a smaller bond angle. So then we have an issue, because we have B as well. So what do we do? So in this case, we have to determine which one is a better answer. So when we are comparing the options in B, in NH3, when you have greater repulsion between the bond pairs, it can space further apart because there is no bond pair. Here is a lone pair. Hence, there's nothing restricting it from moving further apart. If you look at NO3-, there are 3 bond pairs and no lone pairs. So since there's no lone pairs, the repulsion between the 3 bond pairs is not going to yield a significant difference in bond angle. So imagine that they repel each other, but the 3 of them are all bond pairs, right? So therefore, there's no space to squeeze. Whereas if you look at NH3 in B, when the bond pairs repel, they can take up more space because the lone pair doesn't need so much space, right? So therefore, they can take up more space. So hence, more repulsion can take place in NH3 as compared to NO3-. So therefore, between B and C, I would say that definitely it fits the bill better, because I can say more definitely the NH3 has a larger bond angle than PH3. Okay, so therefore, I would say that for C, the bond angles would be similar. The bond angles of CO3 2- and NO3- would both be about 120. So hence, I would cross it out. And lastly, SiCl4. So Si has 4 valence electrons. So therefore, since it's bonded to 4Cl, there'll be 4 bond pairs, 0 lone pair. That will be tetrahedral with a bond angle of 109.5 degrees. So that will look something like that. Okay, and then Pf4 plus. So P has 5 valence electrons. Plus means that it has lost 1 electron. So where will it lose it from? It will always lose electron from the less electronegative atom, because the less electronegative atom is less able to hold on to that shared pair of electrons. Over here, between P and F, P is less electronegative. Hence, 1 electron is lost from P, so P will only have 4 valence electrons. Therefore, it will be just nice. And you will have tetrahedral after losing 1 electron from P. So this is also 4 bond pair, 0 lone pair, also tetrahedral. Okay, so over here, let's take a look whether there's any significant difference in the bond angle. So F is more electronegative than Cl. So F will pull the bond pair of electrons closer to itself. So therefore, over here, SCl4 will experience greater repulsion between the bond pairs since the bond pairs are closer together to each other. So therefore, there will be a larger bond angle. So therefore, this does not fit into point number 2. SiCl4 does not have a smaller bond angle. Hence, the answer is B. Thank you for watching and hope to see you again next week. Bye.